Alright guys, this is my second reassessment attempt on forces, and the question I chose is number 77 from the book, and the question asks, a 3.0 kilogram block is at rest on a horizontal floor. If you push horizontally on a 3.0 kilogram block with a force of 12 newtons, it just starts to move. And the first question asks, what is the coefficient of static friction? So what I do here is I draw my diagram. It's a block, and it's got a normal force acting on it, and the force of gravity. My known values, M1 is 3.0 kilograms, and my gravity 9.8 meters per second squared. So I start off by finding the sum of the forces in the y direction. So I have my force of y in the y directions is N normal force minus the force of gravity times the mass of the object. I manipulate the formula a little bit to where I can get it to be normal force is equal to the force of mass times gravity. And when I multiply that together, I get for my normal force, I get 29.4 newtons. So from here, like they said before, they're looking for the coefficient of static friction. The formula for the coefficient of static friction is force is equal to that little symbol, meaning static friction, coefficient of static friction, times normal force. So what I do here is I manipulate the formula a little bit. Being that we already know the force acting on the object, I can divide both sides by the normal force to get me my coefficient of static friction, which will give me a formula of coefficient of static friction is equal to F over N, and that can be solved, and it gives me 0.400 for the first part is the static friction. The second part of the question asks, it says that a 7.0 kilogram block is stacked on top of the 3.0 kilogram block. What is the magnitude F of the force acting horizontally on the 3.0 kilogram block? As before, that is required to make the two blocks start to move. Alright, so well, now I have my other known values. My M2 is equal to 7.0 kilograms, and my force is 12.0 newtons. So what I do here is I redraw my diagram. I have this block 2 of 12.0 kilograms sitting on top of block of 3.0 kilograms. So what I do here is I find some of the forces in the y direction again, which is just N minus M total of G. M total G is because I added the mass of the two blocks together. Gives me 15 kilograms, and I multiply that by times 9.8 meters per second squared, which is gravity, and it gives me 147 newtons. And I pretty much just plug in my values for F is equal to the coefficient of static friction times normal force, and I use the coefficient of static friction that I found earlier, which is 0.400. I multiply that by the sum of the forces in the y direction, or the normal force, with the blocks sitting on top of each other, 147 newtons, and that gives me 58.8 newtons.